Okay, kids, we're in class. I have my mask. Everyone's got a mask on, and I got a question. Section 1.6, section question 3. So we are definitely going to follow grass. So if your parents ask you, what did you learn in school today? You can tell them I learned how to use grass. But anyway, we always do the G and we draw a picture. So a plane traveling at 42 meters per second west down a runway begins accelerating at 2.8 meters per second squared west. What is the plane's velocity after 5 seconds? How far has it traveled during the 5-second interval? Well, right off the bat, the first thing I'm going to do is I'm going to make a let statement here. Let west be represented by positive values. I don't like up, down, west, south, the rest of it forward. No, we do this. Especially if you're thinking about taking another physics course, this is the way to do it. Then I draw a picture. Here's the runway. I always draw a picture. I've been doing this for decades. I still draw a picture. There is the runway. And a plane is traveling at 52 meters per second west. So I'm going to draw the airplane. There's the airplane. There's the wing. There's like the wheels on it. There it is. Okay, I always draw a picture. And I know that when the plane is right there, it's traveling at 52 meters per second. So I have to assign a symbol to that. I need to know what quantity this is. Well, this is the start of the motion. So this is velocity initial, positive 52 meters per second. Velocity initial. So, and it's going down a runway and it begins to accelerate. Aha, they're giving me more information. That means as this is moving forward here, so it's moving forward, as it's moving forward, it has a known acceleration. And it is 2.8 meters per second squared west. I don't use west. Positive 2.8 meters per second squared. I don't use the west. I use the positive. Okay. What is the plane's velocity after 5 seconds of traveling? Aha, more given information. It's going to travel for 5 seconds. You notice I don't worry about putting a positive or negative in front of it. It's a scalar, right? Velocity initial is a vector. I need a direction, positive. Acceleration is a vector. I need a direction, positive. So now they want us to find certain things. R for required. The first thing they want us to find is final velocity. How fast is it moving after the 5 seconds worth of traveling? Okay. So the next step is A for analysis. This is where, and I hope everybody has made an equation sheet, and we used 5 equations of motion. Okay? You look at the equations of motion, say, which one's going to work? Well, it better have final velocity in it because I need it. Right? It better have initial velocity. It better have time in it. Right? And it better have acceleration in it. So you have to find an equation that matches those conditions. Such an equation does exist. The solution is never this. Mr. Zafiro, this question is impossible. I can't find the equation. You're not looking hard enough. Okay, you're not looking hard enough. So look, here's the equation. Acceleration is equal to final velocity minus initial velocity, because I know initial velocity, I know acceleration, all over time. That's the equation. Now, here's where you have a choice. You can either rearrange this equation right now, use your knowledge of algebra, or if you don't want to do that, you can substitute right now. It's entirely up to you. You get the same marks. Okay, it's entirely up to you. So let's try substituting. It's fun. So When I substitute, I put brackets all the time. So look, bracket plus 2.8 meter per second squared, close the bracket, equals final velocity. That's what I want to solve for. Minus initial velocity. I know what that is. Positive 52 meters per second. Close the bracket. All over time. 5 seconds. There it is. Okay. Now, if that looks confusing to you, you can take a little detour here and do this. Watch. You can say, I'm just going to worry about the numbers. Okay. Positive 2.8. Okay. Equals velocity final. Minus, look, the minus and the positive give me minus 52. Okay. All over 5. So it looks cleaner, right? Maybe it doesn't confuse you. Okay. Maybe it doesn't confuse you. So now I got to solve for this. Well, the first thing you're going to do is multiply both sides by 5. The reason I'm doing that is I want the cancellation here. So I get 5 times positive 2.8 is equal to velocity final minus the 52. So kids, in actuality, what we're doing here is isolating for the unknown variable, which you've done in math class many times. So then what happens is, look, I got to bring this over to the other side. I have to finish my variable isolation. So it becomes 5 times positive 28. This comes over and it became positive 52 is equal to velocity final. So now I get my handy dandy fancy dancy calculator out and I calculate. Give me a moment for those of you watching at home. And I get 192. Okay. Oh, I made a mistake. It's not 192. I multiplied by 28 instead of 2.8. So let me do that again. 5 times 2.8 plus 52, much better, 66. 66 is equal to velocity final. We're almost done. The last step is solution. Here we got to do the nice solution, velocity final. We have to put a direction in. It was positive, right? 66. And we have to put in the unit. It has to be all nice and neat and tidy with a plus or minus sign for direction, a number to show the magnitude, and a unit. It's got to be nice and neat. Okay, and you've done the first part of this. So here we go. We're back. Part B. So the given is the same, but whoops, here we go. Part B, the given is the same. Required, part B, is how far has it traveled in 5 seconds? So displacement, how far has it traveled, right? So analysis, you have to ask yourself a question. What equation will I use with all the given information that I have, right? You got to pick an equation that you can use. And you pick from the 5. You always pick from the 5. So I've been doing this for a while. I know this is the equation. Delta D equals VI delta T plus half A delta T squared. I know that. I've been doing this a while, okay? So there's required analysis, substitution. Let me get another color here. VI, I think, was what? Positive 52. So positive 52 meters per second. It was traveling for 5 seconds plus a half times the acceleration was positive 2.8, positive 2.8 meter per second squared, right? Time was 5 seconds, and we square it. So now we get our handy dandy, fancy dancy, supercalifragilisticexpialidocious calculator out, and we do our work. For those of you at home, please be patient. $295 positive. So here's my solution. Displacement equals positive. That gives me the direction. 295 meters, and we're done. And listen to me carefully. Listen to me now. Don't forget about it later. I am the Terminator. Okay? This is the way I want your answers to look when you hand in your assignment. I expect structure. I expect you to do these questions the way I showed you to do them in the videos and in this particular example. I don't expect you to invent some new way of doing it. Trust me, if you do it my way, when you go on to college or university, you will thank me. Okay? You will thank me that you have fallen into this practice of extreme structure. Okay, bye.